Thank you very much, Lisa. It's a great pleasure and a privilege to be here. I recall the time when I was doing my doctoral work at the North Carolina State University. During the course of the semester, students would rate their professors on the basis of what they thought was their capability. And this was published in the student newspaper. So now that you have revealed that I'm an honorary professor, I'm a little worried at the end of this lecture, you might get a massive feedback from the students that you made a terrible mistake by appointing me as honorary professor. If that happens, I hope at least I'll get a second chance, because this is the first time I'm addressing students in this university. And I'm delighted to be here because I think quite apart from all the scientific and technical work that you're doing in this university, I also value the kind of philosophy that's driving the work of this university. And I believe it's critically important that irrespective of what we do in any particular discipline or field, we have to keep the larger context in mind. Because after all, education is there not to make you good engineers or scientists or medical specialists, but also to make you better citizens. Of course, better citizens of Finland, for those of you who are from Finland, but better citizens of planet Earth for all of us, irrespective of where you come from. And that's essentially what I'm going to talk about today. The title of my talk is Protecting the Global Commons and Tackling Climate Change. Firstly, let me go back in time to 1968, when there was a biologist by the name of Garrett Hardin in the US who wrote a seminal paper on the tragedy of the commons. What he talked about basically was the fact that all of us throughout history and across this globe, in every section of society, have been using resources which are common, but for which nobody is necessarily responsible. And he calls this the tragedy of the commons. He starts by taking a very simple example of, let's say, pasture land, where everybody brings his or her sheep or cow or any other head of cattle. And all these animals graze on that pasture, but nobody is responsible for maintaining it. So over a period of time, particularly if there's overuse or overexploitation of that resource, you would find a significant degradation of that particular pasture. And this he calls the tragedy of the commons, because in some sense, this goes against Adam Smith's belief in the hidden hand, which of course creates market activity, but that market activity is also supposed to promote human welfare. Yes and no. In a number of cases, these are coincidental, but in a growing number of cases, you find a diversion between what is of benefit to an individual and what is of benefit to society at large. So when you talk about the global commons, you're really talking about those resources which are, you might say, unowned natural resources. These are not owned by anybody. These include the Earth's atmosphere. We all use the atmosphere. We live on the atmosphere. We breathe the atmosphere, but we don't own it. And therefore, we have no accountability and we have no responsibility to the atmosphere. This is also true of the ocean floor. Nobody owns it except to the extent of the economic jurisdiction of every country. Antarctica is also a global commons, and outer space. Now, all these resources are central for life because we use them in a variety of ways to support life of various kinds, not just lives of human beings, but every living species. And therefore, I think these are vital to the existence and the good health of everything that lives on this planet. Now, just to give you a few definitions that may be of relevance over here. The World Conservation Strategy, this was something that was published in 1980, developed by the International Union for Conservation of Nature, that's IUCN, and in collaboration with UNESCO and UNEP, as well as the World Wildlife Fund, WWF. And what it says is that a commons is a tract of land or water owned jointly by the members of a community. The global commons includes those parts of the Earth's surface beyond natural jurisdictions, notably the open ocean and the living resources found there or held in common, notably the atmosphere. And the only landmass that may be regarded as part of the global commons is Antarctica, because nobody owns Antarctica. Almost every other part of land area on this planet is owned by someone or the other. And there was a time when you had massive colonization of some parts of the earth. At that stage, the ownership, in a sense, extended to countries and lands that did not historically belong to the colonial powers. And Greenland, incidentally, is still a protectorate of Denmark. And I've been to Greenland. One would expect that that would also be part of the global commons. But in actual fact, it's not. It is part of Denmark. It's, in a sense, under the ownership of Denmark. Now, what are the kinds of global commons that we should be concerned about protecting? Well, firstly, let's look at biodiversity. And I refer to a paper by Rodolfo D'Urso and Peter Raven. Peter Raven is a very well-known botanist who has been responsible for the Missouri Botanical Gardens in the US, in St. Louis, Missouri. It's supposed to be one of the best and richest botanical gardens in the world. And he and Rodolfo D'Urso, who I believe is a Mexican, have come up with an estimate of biodiversity. And I quote what they have written: biodiversity, a central component of Earth's life support systems, is directly relevant to human societies. And they say, we examine the dimensions and nature of the Earth's terrestrial biodiversity and review the scientific facts concerning the rate of loss of biodiversity and the drivers of this loss. The estimate for the total number of species of eukaryotic organisms possible lies in the 5 to 15 million range. And these terms like eukaryotic and other biological terms, I was forced to learn because several years ago in my institute, we set up a biotechnology program, and I didn't want to be totally illiterate on what biotechnology represents. So I picked up a whole lot of fat books on botany and biotechnology and tried to learn a few words so that I don't seem totally unintelligent when I speak to a botanist or biotechnologist. However, as you know, most animal species and plants belong to this family, and the total number of these possibly lies in the 5 to 15 million range, with the best guess of. Now, species diversity is unevenly distributed. The highest concentrations are in tropical ecosystems. That's where you have the richest form of life. And this is true of plant life as well as other species. And therefore, I think it's of deep concern that these tropical biodiversity hotspots are the ones that are the most threatened at this point of time. Now, endemisms are concentrated in a few hotspots, which are in turn seriously threatened by habitat destruction, the most prominent driver of biodiversity loss. So it is human society and the extension of habitat, human habitat, that is clearly the biggest threat to biodiversity on this planet. And this is to be expected because if you look at the growth of population at the beginning of the 20th century, guess what the population of this planet was? 2 billion people. And in this short period of a little more than a century, we have grown to 7 billion. And in the next 30 years, projections tell us that we would reach 9 billion. So in other words, what it took thousands of years to reach as a population of 2 billion, we are adding in the next 30 odd years. And what is even worse is the fact that each human being today consumes and exploits more and more of these species, and therefore we necessarily are expanding our footprint and making it much heavier, which clearly threatens all these hotspots, which are so rich in the gift of life of various kinds, and we are clearly threatening it in a big way. For the past 300 years, recorded extinctions for a few groups of organisms reveal rates of extinction at least several hundred times the rate expected on the basis of the geological record. So in other words, what happened over geological and millennial timescales, we have been able to exceed several hundred times over in the last 300 years, essentially since industrialization began. The loss of biodiversity is the only truly irreversible global environmental change the Earth faces today. Some of you may have seen the movie Jurassic Park. Now that's science fiction. Maybe we'll reach a stage in the next few decades when we can recreate dinosaurs. I wouldn't like to be around if they're dinosaurs. It's enough to deal with aggressive human beings, but imagine if you're confronted with hundreds of dinosaurs just waiting to make a little appetizer out of you. I certainly wouldn't want to oblige that large number of dinosaurs. So, I think we need to accept the fact that biodiversity is the only truly irreversible global environmental change the Earth faces today. And biodiversity is clearly an important part of the global commons. Let's also look at the oceans, and I'm now quoting something from the fourth assessment report of the Intergovernmental Panel on Climate Change, which I have the privilege of chairing. And what we said in the fourth assessment report was the uptake of anthropogenic carbon since 1750 has led to the ocean becoming more acidic, with an average decrease in pH of 0.1 units. Now this may seem very small, but this is revolutionary in terms of the life that exists in the oceans. And increasing atmospheric CO2 concentrations lead to further acidification, because the oceans have been a great source of help to us. While we have been producing huge quantities of carbon dioxide and pumping it into the atmosphere, the oceans have been very kind to us, and they've been absorbing a huge amount of it. But in the bargain, they have increased the level of acidity that you find in the oceans. And projections based on IPCC scenarios give a reduction in average global surface ocean pH of between 0.14 and 0.35 units over the 21st century. So if we don't do anything about this problem, we are really going to convert the oceans of this earth into a huge crucible of acid. And that clearly has major implications for those forms of life which live in it. While the effects of observed ocean acidification on the marine biosphere are as yet undocumented, because this is an area where you need extensive time series observation to be able to arrive at what changes are taking place, and then you would have to attribute those changes to the acidification of the ocean. There are a whole lot of other changes that are taking place. So to be able to identify and pinpoint what is attributable to acidification is certainly a very complex exercise. And therefore, we don't have enough observations to come up with conclusions. But we must accept the fact that the progressive acidification of oceans is expected to have negative impacts on marine shell-forming organisms and their dependent species. I just met somebody who has been to the Andaman Islands, and the Andaman Islands, as you know, are a group of islands off the coast of India, the mainland coast of India, on the way to Indonesia and beyond eastwards. And he was telling me that the corals over there have been completely destroyed. And I think one factor is, of course, acidification, but also possibly the increase in heat in the oceans is another factor. Now, here may I emphasize the fact that one major commons which we have played around with in a way that's not only going to affect and is affecting our lives today, but will certainly affect the lives of future generations, is the Earth's atmosphere. What we have done is to have pumped large quantities of greenhouse gases into this atmosphere, as a result of which climate change is taking place. Now, let me turn to another concept, having talked about the commons. In 1987, the Brundtland Commission, which is known as the World Commission on Environment and Development, published its report, and they popularized a notion which was at that stage not very well known, namely that of sustainable development. And they gave a very simple definition of sustainable development. They defined it as that form of development which helps to meet the needs of the present generation without compromising on the ability of future generations to meet their own needs. Now, I'm giving you this definition only because changes in the climate system of the Earth, of course, are affecting our lives today, and I'll go into some details with respect to that. But they will certainly have a major impact on the ability of future generations to be able to meet their own needs. Because if you're changing the climate of this Earth, and this obviously is going to have major implications for every human activity, then we are making it much more difficult for future generations to be able to meet their own needs. Now, what does the increase in concentration of greenhouse gases in the Earth's atmosphere imply? In the fourth assessment report of the IPCC, we came up with a very clear, simple, but effective statement. What we said is, warming of the climate system is unequivocal. That means there is no doubt about it. As is now evident from observations of increases in global average air and ocean temperatures, widespread melting of snow and ice, and rising global average sea level. Now, these are changes which we are measuring. These are changes on which we have 150, 200 years of observations, and therefore, we know that warming of the climate system is unequivocal. That means it is beyond doubt. We also said very clearly that most of the observed increase in global average temperatures since the mid-20th century is very likely due to the observed increase in anthropogenic greenhouse gas concentrations. Let me explain this. When we say that most of the increase that has taken place since the middle of the last century is very likely on account of anthropogenic, that means human-induced increase in concentration of greenhouse gases, we are basically saying, since the term very likely indicates that there's a 90% or higher chance that we human beings are responsible for the increase in temperature that has taken place since the middle of the last century. Now, these are two important statements because we have said this with a great deal of backup information, analysis, and data. And I would like to emphasize some of the major impacts of climate change. There are several long-term changes in the climate that have been observed, and these include changes in Arctic temperatures. You're aware of that because you are in that region. You know how rapidly the Arctic is melting. Widespread changes in precipitation amounts. That means both rainfall and snow patterns are changing. Ocean salinity, which I've just dealt with, wind patterns and aspects of extreme weather, including droughts, heavy precipitation, heat waves, and the intensity of tropical cyclones. So all these changes, we had very clearly said, are obviously going to affect all forms of life, and most definitely they would affect the lives of human society. Let me give you some examples. If you look at regional impacts, we stated that in Africa, by 2020, we would have 75 to 250 million people projected to be exposed to increased water stress due to climate change. So this is a large number of people, 75 to 250 million people living in a state of water stress on the continent of Africa alone as a result of climate change. And you know very well that Africa and parts of Africa are already areas where you have a number of existing stresses. So climate change is going to exacerbate, it is going to multiply, it's going to compound the stresses that already exist. And that's something that we need to keep in mind. Agricultural production also in Africa, including access to food in many African countries, is projected to be severely compromised. Here again, you must remember that in Africa, a large number of farmers are dependent on rain-fed agriculture. And they're normally small-scale farmers. They produce barely enough to take care of their own needs. And if there's going to be a decline in their own productivity, then clearly there's going to be an increase in malnutrition and hunger, which is certainly something that we cannot accept as responsible citizens. So food security and malnutrition would be affected as a result. And we also said that by 2080, an increase of 5 to 8% of arid and semi-arid land in Africa is projected under a range of climate scenarios. So, you'll get an increase of arid and semi-arid land in Africa by 5 to 8%. And there's already a large area over there which consists of desert conditions, and therefore we are going to add to that as a result of climate change. Now, we also said that towards the end of the 21st century, projected sea level rise will affect low-lying coastal areas with large populations. And the cost of adaptation could amount to at least 5 to 10% of gross domestic product. There are countries in the world which are very, very poor, and for them to set aside 5 to 10% of their GDP for adaptation measures is a huge luxury which cannot possibly take place. On the other hand, let me give you the example of the Netherlands, which several hundred years ago was a set of small settlements in somewhat higher areas. When the people of the Netherlands decided that they need a little more land, so they decided to keep the water out. They created some dikes, and that increased the land area that they had. And all of these land areas, then they decided to join together by constructing a dike in the north, which would keep the sea out. Now that took a fair amount of investment. And today, as you're probably aware, the Netherlands is spending a lot of money on a regular basis, not only on maintaining the dikes, which are essential since a large part of that country is below sea level, but they're also strengthening and raising the height of these dikes because they're preparing for the future. With sea level rise, they possibly will have to deal with a new set of conditions which they would like to be prepared for. Now, the Netherlands is by and large a rich country. They can afford to do it. But can Bangladesh do it with a large coastline? Bangladesh has a huge coastline, and if they were to invest in setting up dikes of the type that the Netherlands has, I don't think they would have the means to be able to do so. They are a poor country. Their GDP levels per capita income levels are extremely low to permit that kind of an investment. The other point I'd like to make is that we could also see some abrupt and irreversible changes in the future. For instance, partial loss of ice sheets on polar land. This means Greenland, the West Antarctic ice sheet, could imply meters of sea level rise, major changes in coastlines and inundation of low-lying areas, with greatest effects in river deltas and low-lying islands. And in fact, we have clearly stated that the most vulnerable regions in the world are the mega deltas, which means cities like Shanghai, Dhaka, Kolkata, because these are mega deltas. They are situated on the delta of each individual river, and it's a large concentration of population. So every time there's a storm surge, every time there's coastal flooding, a very large number of people will be affected, and a substantial amount of property will also be affected. Now, I also want to mention that if temperatures exceed 1.5 to 2.5 degrees Celsius, then 20 to 30% of the species which we have assessed would be at the threat of extinction. And here let me clarify that when I talk about 1.5 to 2.5 degrees Celsius, that's relative to the temperature that existed at the end of the last century. So in other words, if in this century of 1.2 to 2.5 degrees or more, we could easily be threatening 20 to 30% of the species that exist. And if temperature increase exceeds 3.5 degrees Celsius, then model projections suggest significant extinctions ranging from 40 to 70% of the species assessed around the globe. Now, that clearly is a scenario that we want to avoid at all cost. Now, you could say, where is the certainty that this will happen? Well, you see, we need to be concerned about even low probability and high impact events. Let's say I was to take a flight. I am taking a flight this evening from here to Helsinki and Helsinki to Delhi. If somebody told me that there's a 5% chance that that plane might crash, I certainly will not take that flight. And I think most of you wouldn't do that unless you were forced to get on that plane. So, I think we as risk averters and rational human beings need to be concerned about high impact events, even if they are associated with very little probability. And I think the precautionary principle requires that we take such outcomes into account and build in features by which we can deal with these risks in the future. Okay, I don't want to continue with bad news, but let me give you another set of important findings that we've come up with, and then I'll give you a little bit of the good news as well, all right? Because as I said earlier, otherwise my honorary professorship might be in danger as much as extreme events create dangers for human society. Well, we brought out a special report on managing the risks of extreme events and disasters to advance climate change adaptation. This was released last year. And we found that based on observations gathered since 1950 of changes in some extremes, we came up with the conclusion that there's very likely been an overall decrease in the number of cold days and nights, and an overall increase in the number of warm days and nights at the global scale. Now, you're in the vicinity of Russia. You know what happened in Russia last year. And we know that heat waves are on the increase everywhere. In 2003, there was a massive heat wave in Europe, particularly in and around Paris, and you know the large number of lives that were lost. We also know for a fact that during the period 1970 to 2008, over 95% of the deaths from natural disasters occurred in developing countries. Why? Because let's compare a major hurricane that hits the coast of Florida. What do people do? Well, they take wooden boards, they nail their windows, get into their SUVs or their pickup trucks and drive off to a safe location. And they just leave their houses as they are, fully protected. What happens when a similar intensity cyclone hits, let's say, Burma or or Bangladesh. You know, I'm deliberately calling Myanmar Burma because less than a month ago we had Aung San Suu Kyi come to my institute in New Delhi, and I started by talking about Myanmar, and she used the term Burma. She doesn't accept the change in name of the country which the military dictatorship has brought about, so she insists on calling it Burma, and I completely changed my tune. I started calling Burma Burma, right? So anyway, in 2008 there was a massive cyclone which hit Burma, and it's estimated that perhaps over 150,000 people died because they have no early warning system. There are no shelters of any kind. Their houses are flimsy huts which even a strong gale can wipe out, leave alone a massive cyclone of that intensity. They really had nowhere to go, so they lost their lives. And at the end of what I'm going to say, I'm going to show you a little film. We immediately took steps to provide lighting to the people who were affected, a very small number compared to their overall needs. But I just want to mention the fact that technology today has to reach some of the most underprivileged people in the world if we want to bring about change in the right direction. So, you know, when you have a disaster, natural disaster, hit a developing country, they really have very little protection. And that's why middle-income countries with rapidly expanding asset bases have generally borne the largest burden. Now, I also want to mention that in economic terms, also developing countries often have to carry a very high burden on account of these extreme events. For instance, in small island developing states, losses expressed as a percentage of GDP have been particularly high, exceeding 1% in many cases, and 8% in the most extreme cases, averaged over both disaster and non-disaster years for the period from 1970 to 2010. So 8% of the GDP is a massive amount of loss. If you're talking about a 4% increase in GDP each year, what this really means is that there's a setback by 2 years in the well-being of a society. Now, 2 points I want to mention very quickly, and then I'll move on to what we can do by way of mitigation. Heat waves are on the increase, both in frequency and intensity. And we have estimated that those heat waves which take place currently once in 20 years, by the end of this century, if we don't do anything, will take place once in 2 years. And of course, in the northern hemisphere and the high latitudes, it is likely to become a 1 in 5 year event. So let's say in Finland, those heat waves which are taking place currently once in 20 years will visit you once in 5 years, which is a fairly serious occurrence. And it's also likely that the frequency of heavy precipitation or the proportion of total rainfall or snow from heavy falls will increase in the 21st century over many areas of the globe. This is particularly the case in the high latitudes and tropical regions, and in winter in the northern mid-latitudes. So heavy rainfalls associated with tropical cyclones are likely to increase with continued warming. So what can we do to deal with this situation? Well, firstly, we have to adapt to this reality of the impacts of climate change. One estimate that we have is that we have already sort of created an insurance for a temperature increase of 0.6 degrees Celsius. In other words, there's so much momentum and inertia in the climate system that even if we were to freeze our emissions at levels that we have, let's say, that we had at the beginning of the century, climate change will continue for several decades. So we have no choice but to adapt to the impacts of climate change. But that's not enough. We will also have to mitigate the emissions of greenhouse gases. We have to collectively and globally make sure that we reduce the emissions of greenhouse gases and stabilize the concentration of greenhouse gases in the atmosphere. Now, in order to do that, there are several measures that can be taken in hand. And here the good news is that fossil energy use is responsible for about 85% of the anthropogenic or human-induced CO2 emissions produced annually. So we need to use fossil energy much more efficiently. That means you can cut down on the use by an improvement in the efficiency of fossil energy use. And the other thing we need to do is to move to renewable sources or non-fossil sources of energy. And this is where I think Finland can get into a leadership position. You don't necessarily have to look at how these technologies will help you, because you don't have too much sunshine. You probably don't have too much wind energy either. You have a lot of biomass, and I think biomass is something that you can concentrate on for conversion into different forms of energy that can be used. But what you also need to do is to make sure that you look at the rest of the world. Because if you develop technologies that have a relevance in China or India or parts of Africa, then you're not only providing the benefits of your scientific and technical expertise to humanity at large, but you're also opening up markets by which your companies and therefore your people will benefit greatly. So I would submit that in a university like this, you need to expand the horizons of what you define as the direction that you need to take and as the activities that you need to promote. And certainly in the case of mitigation, there are substantial opportunities that are going to come up globally. In fact, we have a number of institutional barriers which are preventing some of these solutions, because we have estimated in the IPCC that in 2030 we would have 6 gigatons of CO2 equivalent mitigation potential, which is available at negative cost. In other words, if you were to take those measures, you would actually make money by doing so. You won't be spending any money. And there's a whole range of other options where you can achieve major reductions in emissions of greenhouse gases at very low cost. Now, I also want to tell you about another special report we brought out last year on renewable energy sources and climate change mitigation. And here we found that even though renewable energy is growing slowly, it is growing definitely. And in the past few years, its growth has been quite encouraging. And even though in general the cost of renewable energy is higher than that of conventional forms of energy, in several applications it is already cost effective. And for that I'm going to show you a little film. And here let me also say that there are about 1.4 billion people in the world who have no access to electricity, and the development of renewable energy solutions would make it possible for them to access electricity which is generated on a decentralized basis. It's also true that there are about 1.3 billion people in addition who use biomass for cooking and heat applications in their homes, and they also would benefit greatly through renewable energy solutions. So renewable energy, quite apart from the aggregate effect at the global level, also has major equity benefits, because you would be able to provide clean and modern energy to those who otherwise will never get this kind of access. We have examined 164 scenarios in this special report, which give you the pathway to development of renewable energy, let's say by the middle of the century. And as you would expect, depending on the policies that are accepted globally, you find a major variation in the contribution of renewable energy to the total energy supply in 2050. And this ranges from about 11% to 77%. I'm mentioning this only to emphasize the fact that if we adopt policies today for development of renewable energy technologies and their promotion, then the results will follow only in the coming decades. And therefore, the essence of what we should do is to see that we start taking action today for the benefit of generations yet to come, and of course, for generations that are clearly going to benefit even today. Now, I want to mention that what we need is a spread of awareness on the scientific reality of climate change. And I think this lack of awareness has affected outcomes so far. And I want to end by asking a few questions, and I hope we'll have time for some questions and answers. The questions I would ask is, why has the application of policies been so modest? Why is the global community not on a faster implementation track? Why have, at the very least, hedging strategies not emerged in many more countries? There are some countries that are doing very well, but others are not. Is the scale of the problem too large for current institutions? Do we have institutional weaknesses that cannot deal with the size of this problem? Is there a lack of information on potential impacts or on low-cost actions? In other words, are we not aware of the implications of inaction and the attractiveness of action? Has policy making been influenced by the special interests of a few? So I'm asking these questions, and maybe you have the wisdom to answer them, because I'm afraid I only have half answers to all of these. So I'll stop here, but we'll show you a brief film which highlights how technology can help some of the most underprivileged in the world. So can we roll the film now? Okay. Can we switch off the light? We need to switch off this light. Yeah. Okay, thank you very much. I'm sorry I spoke longer than I should have, but I hope we have a few minutes for questions and answers.